So in example 2 here, we are going to graph a fourth degree polynomial. Now polynomials will not have any asymptotes, so we're going to concentrate on f prime, f double prime, increase, decrease, concavity. F prime of x here is just going to be 4x cubed minus 16x. We've got a common 4 we can factor out and also an x. So we can bring a 4x out of here. Let's see, we will have an x squared left minus 4. We will set that equals 0. So then that's going to give us either 4x equals 0, in which case x equals 0, or x squared minus 4 equals 0, in which case x squared equals 4, and taking square roots, x is plus or minus 2. Now we'll do a sign analysis for f prime. So our cutoffs, our critical numbers are 0 and plus or minus 2. So we've got 0 in the middle here, 2 and negative 2. We'll pick a test number in each region. How about -3, -1, 1, and +3? And then we're going to plug into our factors of f double prime. So we've got a 4x. We got an x squared minus 4. The product of those makes f prime. And then f we'll put below. So -3 in here for x. -3 times 4 is -12, so that's negative. -3 in here. -3 squared is 9 minus 4, that's positive. Negative divided by positive is negative. F is decreasing. Plug in a -1. -1 times 4, negative. -1 squared is 1 minus 4, that's negative. Negative times negative, positive. F is increasing. Plug in a 1. 1 times 4, positive. 1 squared minus 4, negative. Positive times negative, negative. F is decreasing. Plug in a 3. 3 times 4, positive. 3 squared is 9 minus 4, positive. Positive times positive is positive. F is increasing. So we are decreasing on the intervals negative infinity to -2, closed, and then also here 0 to 2. And then increasing -2 to 0 and 2 to infinity. So -2 to 0 and 2 to infinity. Then since it's decreasing and then increasing, we have a min at -2. And then decreasing, increasing here, a min at +2. And then increase, decrease, we're going to have a max at 0. So to find those min and max values, we want to plug in the original function. So plus or minus 2, I plugged into the original function here. So I gave a 4th power minus 8 times plus or minus 2 squared, which gives me a -16. So we'll have 2 -16 and -2 -16. 0, if you plug in the function, here you get 0 to the 4th minus 8 times 0 squared, which is 0. So here is our maximum and minimum points. Our local max is 0, so our max actually is the y value. So max equals 0, and the min is -16, the y value. Now we'll look at f double prime. So we want to take a derivative here. 3 times 4 is 12, x squared right there. Derivative of -16x is -16. Set that equals 0. Let's see, we have a common 4 that we can factor out. That'll leave us 3x squared minus 4. and set that equals 0. So then 4 is never 0, so set 3x squared minus 4 equals 0. Bring the 4 over, 3x squared equals 4. Divide both sides by 3, x squared equals 4/3. And then take square roots on both sides. And that gives us x is plus or minus square root of 4/3. Square root of 4 up top is 2, and then the root 3 on the bottom, we got to leave it. So those turn out to be about plus or minus 1.15. So those are our critical numbers for f prime. So determine our concavity here. So we had that 0 in the middle, and our -2 here, let's just kind of bring those down, and a 2 there. But our critical numbers for f double prime are the plus or minus 1.15. So about right here, negative 1.15, and about right here, positive 1.15. For test numbers, we could use -2, 0, and +2. And we will plug those. We could just plug right in here into our f double prime. So f double prime above the number line, and then f below. So let's see, plug a -2 in. So 12 times -2 squared. 12 times 4 is 48 minus 16. That is positive. This will be concave up. Plug a 0 in. That'll zero out this term. Minus 16 is negative. Concave down. Plug a 2 in. 12 times 2 squared, 48 minus 16. Positive. That's concave up. So now let's put things together. So we're decreasing. We look here, we're concave up. We look up above. We're decreasing up to -2. So that means then that we're decreasing concave up to here. And then to the right of -2, now we're increasing, but still concave up. So in between -2 and -1.15, we're increasing concave up like that. Increasing and concave down here between -1.15 and 0. Decreasing and concave down here between 0 and 1.15. So if I just break that up into pieces like that, so increasing concave down, decreasing concave down. Between 1.15 and 2, we're concave up. We look up here, we're decreasing. So decreasing concave up would look like this piece here. And then to the right of 2, we're increasing, we're concave up. So increasing concave up right there. And we kind of see this W forming. And that's actually going to be the shape of our graph. We change from concave up here to concave down there. So it'll be an inflection point here, concave down to concave up. There'll be another inflection point at 1.15. So let's go ahead and scroll down a little bit. So now we want to go ahead and do our graph here. Intercepts are good to find. We already found ours. X equals 0. We got 0, 0. Now if we set y equals 0, well, here's our function, x to the 4th minus 8x squared. We can factor an x squared out of there here. And we'll have left x squared minus 8. Set that equals 0, which means either x squared is 0, in which case x equals 0. We already got that one. Or x squared minus 8 is equal to 0, in which case x squared equals 8. Take square roots on both sides. X is plus or minus root 8. So we have intercepts at plus or minus root 8, which is about, I think that's about 2.2. It's between 2 and 3. If we set x equals 0, we get y equals 0. So 0, 0 is a point on the graph. And in fact, that was our maximum point there. And then if we take our plus or minus 1.15 and plug it in, so that's right here, plus or minus 2 over root 3. So I plug that in the original function, give a 4th power minus 8 times a square, we get negative 8.88. So if we put things together, let me go ahead and grab our number lines and bring them down here, or bring copies of them down. So we've got them on the same screen. So let's go ahead and get our x and y axis going. So here is 0, x equals 0. That's going to be our y axis. And then x-axis here. Let's go ahead and line things up. So that's a 2, negative 2. So we've got 0, 0 as a point on the graph. The other intercepts are at plus or minus root 8, which is about 2.2. So it'd be about right here and about right there. So those are our intercepts, x-intercepts. And then let's see, we also had our max and min points. So we went back up here. Those were at 2, negative 16, negative 2, negative 16. So 2, negative 16, let's put that down here. And negative 2, negative 16 right there. And then we've got negative 8.88 is the y-coordinate of our inflection points. And those were the x-coordinates of negative 1.15. So negative 1.15, negative 8.88 would be about right there. Positive 1.15 here, negative 8.88 about right there. And then we just connect things up here. This will be decreasing concave up. So that's this portion of the graph. And then we're increasing concave up here. Then we change to increasing concave down like this. Decreasing concave down like that, decreasing concave up here, and increasing concave up here. And we get that W shape. And then we can double check this in Desmos if we want here. And let's go ahead and do that real quick. So let's see here. Go and Desmos. So let's see, y equals, we had x to the 4th minus, and what was that, 8x squared. And zoom out a little bit, and we are indeed seeing our W shape here. So that's confirming what we did by hand.